Hello dear students. Let us now discuss about the subtopic stack and subroutine of your unit 6 microprocessor and interfacing chapter. These are the outlines of the lecture. What is stack? What is subroutine? Instruction used for stack operation, time delay and time delay using register pair. So first of all, let us have some idea that what is actually stack. Stack is a part of memory which the processor use for temporary storage of information, and the stack has a LIFO structure. Means what? Whenever we put data into the stack, suppose we are putting a data at the very last, then at the time of retrieval that data will be the first one. The stack normally grows backward into memory. Means what? Suppose the programmer has decided, the programmer defines the bottom of the stack and the stack grows into reducing address the stack. In the 8085, stack is defined by the setting the stack pointer register. First of all, we have to set the stack pointer register. SP stands for stack pointer. It is a special type of register which is having 16-bit address. In this instruction, LXI, SP, FFFFH, what we have done, it loads the 16-bit memory location in stack pointer. Means in stack pointer, now the programmer has to identify from where the stack operation can be performed, and that memory location can be initialized with the help of this instruction LXI SP stands for stack pointer, and after that 16-bit address. So this can be, the syntax will be LXI SP comma, this will be 16-bit address from where we can start the stack operation. The size of the stack is limited only by the available memory. It is a part of the main memory. So suppose this is a main memory section, this is suppose a main memory section, then suppose the programmer has decided this to this much part to use as stack. This stack memory will be the part of the main memory. So these are the instruction used for stack. First one is LXI SP 16-bit address. For initialization of the stack pointer, we are using LXI stack pointer 16-bit address from where we have to start the stack operation. The second one, push register. The operand will be one register. This register could be any general purpose register like B, D, H. Copies contents of register pair on the stack. Okay, it will copy the content of register pair. Suppose we are writing push B, it will copy the content of register pair B and C both on the stack. So pop register, again here also we can see, if suppose I am writing pop B, then automatically it will copy the content of top two memory location of the stack into specified register pair. Means it will copy the content of the stack register or the content of stack into B and C register pair. Come to the fourth one, that is push PSW. PSW means program status word. Program status word is the accumulator plus flag register. Together we call this accumulator and flag register as program status word. Like push, the program status word instruction for pop will be pop PSW, and it copies the content of top two memory locations of the stack in accumulator and flags. This is one example through which we can easily understand how the instruction work. Exchanging the content of D register pair with H register pair using stack. There is D register pair, this will be D and E, okay, and there is register pair H and L, and the content of D register pair will be exchanged with HL register pair with the help of stack. This is the question. Here the stack pointer value, or from which location we will start the stack operation, it is given, that is 5555H. It is given 5555H. First we have to initialize the stack pointer value as 5555H. It is written over here LXI SP 5555H. In H register pair, suppose we are taking two data for HL and for DE as 1, 2, 3, 4. Any data you can consider. I am considering this 1, 2, 3, 4 for HL register pair and 5, 6, 7, 8 for DE register pair. Ultimately, what we have to do? We have to exchange these two data with the help of stack operation. So first we have to write push D. In this line, what the processor will do, push D, means the stack pointer, when we execute this line push D, what will happen? DE, this is having 56 and 78, but at the first position or the higher memory location, what it will contain? This is 56 and the lower register pair it will 78. Then after the execution of this instruction line, then automatically this 56 will be pushed to the next memory location of the stack. This 78 will be in the next location. Stack pointer value, this instruction is a 2-byte instruction. Then stack pointer value will be decremented to 2 value. Means at the beginning the stack pointer value was 5555 and now the stack pointer value will be 5553. Okay, and this stack pointer will come to this position now. Next line will push H. What will happen in this instruction? Push H. H is containing 12 and L is containing 34. Then push H, it will move 12 to this location and 34 to this location. And the stack pointer value also again it will change to 5551. After these two lines, we are having the third line as pop D. It will retrieve the data from the top of the stack over here. Then it will put this 34 lower order address 34 into E register and again 12 for D register. Then automatically this DE will be 1, 2, 3, 4. Whereas we perform pop H, the 78 and 56 will be. So with the help of this program, what we have done? We have done the content of H register pair was 1, 2, 3, 4 and the content of D register pair was 5, 6, 7, 8. Now the content of DE register is 1, 2, 3, 4, whereas HL register pair it is containing the value as 5, 6, 7, 8. So with the help of this program, the stack operation can be easily understood. Now come to the second part, that what is subroutine. Suppose we are writing a main program and the program body is over here. In the main program, there is one instruction which we need to perform again and again within the program. We have to write a small program outside the main program, and whenever in the main program it is required, then we can call that, or this sub part is known as subroutine. In subroutine we can call again and again into the main program. Whenever we return to the main program from the subroutine, we require an instruction called as RET or return. A subroutine is a group of instructions that performs a repeated subtask. The subroutine can be called many times in a program. Advantages of using subroutine is what? Instead of writing some instructions several times, they can be grouped into subroutine and can be called whenever it is required. Where the subroutine lies, generally the subroutine is placed or written outside the main program. So I have described to you, it will use call instruction, and to return from the subroutine it will use the return instruction RET. The call instruction, what will be the syntax? Call, after the call instruction, the 16-bit address from where the subroutine actually starts. So suppose I am writing a call C100H, means what? From C100H the subroutine actually begins. Suppose this is a subroutine, and from C100 this subroutine will begin. This line transfers the program sequence to the memory address given in operand. To return from the subroutine, we require another instruction that is known as return or RET. It will not take any operand. Now come to another example of call and return instruction. Suppose this is the 8050 program counter. The program execution starts. The first line MVI A, 25, in the accumulator we are putting the data as 25H, and as this instruction line is of 2 byte and the program counter value will be now 8052, and after that the second line of instruction, it will contain MVI B, 35, means in the B register now we will have the data as 35. In the third line we are executing call instruction, and after that we have identified a label. After the call instruction we have identified, or we are putting the label for the subroutine. Call label. Label is nothing but a address. Label is nothing but an address from where the subroutine actually starts. Here the label or the subroutine starts from the location 9050. Okay, and in that location it is written the sub program or the sub part of the program as add B. Means whenever we execute this third line call label, the program counter value will automatically move to this location 9050, and it will execute the code. What it will do? Add B. After this instruction we have written here RET, means it will come back to the main program again with the help of this instruction RET. Okay, so it will end your topic here. If any query, then you can mail me.